Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Space Telescope is absolutely killing it this year with jaw-dropping discoveries that are rewriting the rules of space. Get this, scientists have found not one, but two alien planets literally falling apart, shedding their outer layers into the void of space like cosmic dandruff. Meanwhile, massive, red monster galaxies are popping up in the early universe and throwing a giant wrench into our theories of how galaxies formed. Oh, and let's not forget the mysterious rogue object zipping through the galaxy at insane speeds, like it's late for a date with destiny. Let's dive in. Thanks to JWST's insane eye for detail, astronomers just made a first-of-its-kind observation. Two distant exoplanets are crumbling before our very eyes. One of them, K22b, is a rocky world about Neptune size, but it's living life on the edge. It orbits its star so fast, a year only takes 9 hours. That's right, 9 hours. The star's extreme heat is literally roasting this planet alive, cranking surface temps up to a sizzling 3,300 degrees Fahrenheit or 1,826 degrees Celsius. The heat is so brutal that the planet's surface is vaporizing into space, leaving behind a glowing, comet-like trail of rock dust. According to Jason Wright, an astronomy professor at Penn State, this gives us a rare and exciting glimpse into the insides of rocky planets, calling it a remarkable and fortuitous opportunity. And that's just one highlight. Buckle up, because JWST is just getting started. But K22b isn't falling apart alone, it's got company. Another crumbling planet with the super catchy name BD plus 054868AB was spotted by NASA's TESS, or Transiting Exoplanet Survey satellite. And here's the wild part, it's the closest disintegrating planet to Earth ever discovered. As Penn State grad student Nick Tusay perfectly put it, these planets are literally spilling their guts into space. And scientists are eating up the data. Around K22b, they've detected rare gases like carbon dioxide and nitric oxide, not something you usually find on a planet like this. These strange signatures could offer major clues into how planets are built, and how they eventually fall apart. But wait, JWST wasn't done blowing minds. This year, it also peered deep into the early universe and spotted gigantic, blazing red monster galaxies pumping out stars at a jaw-dropping pace. These cosmic beasts are completely flipping the script on what scientists thought they knew about galaxy formation. JWST revealed that the early universe was packed with 10 to 100 times more galaxies than we ever imagined. And not just tiny ones, some were shockingly massive and well-structured way earlier than expected. At one point, astronomers thought they had stumbled upon the impossible, galaxies so massive they shouldn't even exist with the amount of material available in the early universe. But after a closer look, it turned out those galaxies weren't as far away as first thought, meaning they weren't quite the cosmic giants we imagined. Still, among 36 galaxies studied, 3 absolute beasts stood out, the so-called red monsters. These galaxies are going all in, turning almost 50% of their available gas into stars. For comparison, our Milky Way is crawling along at a pace 500 times slower. So how did these monsters bulk up so fast? One theory points to cosmic filaments, massive strands of matter that connect galaxies across the universe. These filaments might have acted like high-speed gas pipelines, feeding early galaxies more efficiently. Another idea? Supermassive black holes could be playing a role, compressing gas and turbocharging star formation like cosmic pressure cookers. We don't have all the answers yet, but this is a huge leap in our understanding of galaxy growth. And just when you think JWST is done surprising us, boom, it finds something weird cruising through our galaxy. Meet SIMP 0136, and yes, that's its real name. It's either a rogue planet wandering solo through the galaxy or a brown dwarf, which is like a star that never quite made it. Thanks to JWST's near-infrared spectrograph, scientists have already picked up some crazy details like clouds made of iron and silicate dust and carbon monoxide and carbon dioxide swirling around. All signs point to SIMP 0136 having one seriously bizarre atmosphere. Not only is it filled with strange clouds and exotic gases, but it's also spinning like crazy, completing a full rotation in just 2.4 hours. That's insanely fast for an object of its size, and it gives JWST a front row seat to collect detailed data in record time. While scientists are still decoding the full chemistry of this strange object's atmosphere, what they've uncovered so far has them buzzing. JWST is showing us details we never thought we'd see from so many light years away, pushing the limits of what's possible in space science. And just when you think that's enough, boom, supernova time. Astronomers just caught one of the most distant supernovas ever recorded, called AT 2023, a DSV. This massive stellar explosion happened around 11.4 billion years ago, which means it went off just 2 billion years after the Big Bang in a galaxy that was basically still a baby. The star behind the blast was a giant, about 20 times the mass of our Sun, and its death unleashed one of the most violent stellar eruptions we've ever witnessed. David Coulter from the JWST team summed it up perfectly. The first stars were nothing like the ones we see today. They were huge, insanely hot, and exploded in absolutely colossal ways. These ancient supernovas? Way more intense and dramatic than anything we see in today's universe. This particular one might be one of the clearest signs yet that the first explosions in the cosmos were on a whole different level, brighter, bigger, and far more violent. Back then, the universe was made up almost entirely of hydrogen and helium, barely any of the heavier stuff that we now call metals in astronomy. The first stars were born from that simple mix, but when they exploded, they seeded the cosmos with heavier elements like oxygen, carbon, and iron. That stardust became the building blocks for newer generations of stars and eventually for us. This supernova gives us an incredible peek into how that cosmic chain reaction first began. Now let's fast forward to something much closer, just 45 million light-years away, in the constellation Canis Major. There lies the galaxy NGC 2283, which recently stole the spotlight thanks to the James Webb Space Telescope. At the heart of this galaxy is a bar-shaped cluster of stars, kind of like a glowing cosmic beacon. Wrapping around it are sweeping, spiral arms filled with gas and newborn stars, creating a vibrant, swirling galactic design. Webb's latest image lit up those star-forming regions, showing brilliant clusters of stars energizing the surrounding hydrogen gas, the raw material for building even more stars. And the story doesn't stop there. When these massive stars reach the end of their lives and explode as supernovas, they send shockwaves of gas and heavy elements, like oxygen and sodium, flying across space. That material gets recycled into new clouds, fueling the birth of even more stars. It's a cosmic feedback loop, the universe constantly reinventing itself. And speaking of supernovas, guess what? NGC 2283 is also home to a spectacular 1SN2023 AXU, a Type II supernova. These explosions happen when a massive star, at least 8 times bigger than our Sun, reaches the end of its life, collapses under its own gravity, and then goes boom. The explosion is so powerful, it doesn't just destroy, it actually helps create. The debris blasted into space can spark the formation of new stars, injecting fresh gas and elements back into the galaxy's ecosystem. Thanks to its powerful infrared vision, JWST captured this explosive event in stunning detail, letting us witness star death and rebirth in action. But the Webb telescope isn't just stargazing, it's also chasing down the universe's biggest mystery, dark matter. Scientists think dark matter makes up about 85% of the universe, yet we can't see it, touch it, or directly detect it. It's like a ghost holding everything together. So how does Webb come into play? Researchers are now hunting for clues in the form of actions, a hypothetical particle that might make up dark matter. These actions are thought to be unstable, and when they break down, they release photons, little packets of light. If actions are really out there, JWST's ultra-sensitive infrared sensors could detect those photons, giving us our first real glimpse into the shadowy world of dark matter. As Elena Panetti, a theoretical astroparticle physicist, said, "If we find this light, it would be groundbreaking, truly the discovery of the century." What scientists are doing right now is basically cosmic detective work, digging through the universe's background noise, following the tiniest of clues, hoping to uncover something we're not even sure exists yet. Trying to spot these elusive photons from axion decay is no easy task. They're incredibly faint, and their signals can easily get lost in the glow of other cosmic light sources. But that's where JWST shines, literally. Its incredible infrared sensitivity makes it the perfect tool to pick up on these ghostly hints of light. The tricky part isn't just detecting the photons, it's figuring out where to look in the vastness of space. Scientists like Christopher Desert are surveying different parts of the Milky Way and beyond, carefully selecting spots where axion activity might show up. And while axion decay doesn't happen often, if actions do make up dark matter, it should happen just enough for Webb to catch them in the act. If successful, this could revolutionize our understanding of the universe, uncovering secrets that have been hidden for billions of years. And while we're chasing the unknown, Webb's also been capturing some truly mesmerizing sights, like Herbig Haro 30, or HH30 for short. This baby star, located in the Taurus constellation, is just 500,000 years old, basically a cosmic newborn, and it's still wrapped in a thick cocoon of gas and dust. We can't see the star itself, but JWST caught something just as epic: powerful jets of gas shooting out from the center, slamming into surrounding material and creating glowing shockwaves. These glowing clouds are pure gold for astronomers. They let us study how planets form right from the earliest stages. The tiny dust grains in HH30's disk, they could one day clump together to become entire worlds. The dust in HH30 might be microscopic, we're talking just a millionth of a meter across, but don't let their size fool you. These tiny particles are the seeds of planets. In the thicker parts of the star's disk, the dust starts clumping together. Over time, those clumps become pebbles, then boulders, and eventually entire planets, forming over millions of years. Meanwhile, back in our own cosmic backyard, NASA's keeping an eye on asteroid 2024, and they're using the James Webb Space Telescope to do it. Why the concern? Well, there's currently a 2.3% chance it could hit Earth in 2032, a noticeable jump from the 1.3% chance just a few weeks ago. The odds are still pretty low, and they'll keep changing as more data rolls in. The good news? Most projections still point to a near miss. But if it were to hit, the impact zone could span a massive area: the Eastern Pacific, parts of South America, the Atlantic Ocean, Africa, the Arabian Sea, and even South Asia. It's currently rated a 3 out of 10 on the Torino Impact Hazard Scale, making it the top potential threat on NASA's radar right now. 2024 is estimated to be between 130 and 300 feet wide, which is 40 to 90 meters, but scientists aren't yet sure exactly how big it is or what it's made of. That's where Webb's mid-infrared camera comes in. NASA is planning key observations in March and May, which should give us much clearer data on the asteroid's true size and composition. And on a more uplifting note, there's also some planet-forming science magic going on. A Canadian-led team of astronomers just made a breakthrough discovery about how young planets take shape, using the James Webb Telescope in a brand new way that's never been done before. Let's zoom in on a young star called PDS 70, located about 370 light-years away. This stellar baby is only 5 million years old, practically a newborn in cosmic terms, and it's surrounded by a swirling disk of gas and dust where two planets are just beginning to take shape. Thanks to the James Webb Space Telescope, astronomers got an unprecedented look at these developing worlds. Using its advanced instruments, they were able to see how these young planets are actually battling their own star for resources, pulling in gas and dust from their environment in a process called accretion. Basically, they're bulking up one particle at a time. To get this level of clarity, the team used a clever trick, a specialized mask that blocked out the blinding light from the star itself, that let them zero in on the planets and the action happening in the disk around them. And Webb didn't stop there. The telescope also cracked open the secrets of the Phoenix Galaxy cluster, a behemoth about 5.8 billion light-years away. This is the largest galaxy cluster ever observed, and its core galaxy has had astronomers scratching their heads. Normally, these central galaxies are considered red and dead. They've burned through their gas and stopped forming stars. But the Phoenix Galaxy is defying expectations, producing a jaw-dropping 1,000 stars per year. That's 1,000 times more than the average galaxy. So what's the secret? In young galaxies, star birth is driven by cold, dense gas. But the Phoenix Galaxy? It's way too old for that. or so we thought. So where is all that star fuel coming from? Well, that's the next mystery scientists are diving into. The big breakthrough came when a research team from UT tapped into the James Webb's powerful infrared vision to peer deeper into the Phoenix cluster's core. What they found was the missing piece of the puzzle: warm gas nestled in the heart of the galaxy. Not scorching hot, not icy cold, just the right temperature. This warm gas is in the sweet spot, slowly cooling down and becoming the perfect fuel for new stars to ignite. For the first time, we've been able to map areas in the core where the gas is in this in-between state, the team shared. It's a major clue in understanding how an old galaxy like this one is still kicking out stars at lightning speed. And that's a wrap on today's cosmic journey through the universe. From planets falling apart to mind-blowing star births, the James Webb Space Telescope continues to reveal the mysteries of space. If you enjoyed this adventure, be sure to like, subscribe, and hit that bell so you never miss an exploration with Spaceverse. Until next time, keep looking up.